This is the short version of my talk on Fermat's method of integration and the hyperbolic curve. Okay, so Pierre de Fermat was interested in finding the area under the curve y equals x to the n between 0 and a. And what he would do is he would construct these rectangles going backwards. So the edge of the first rectangle would be A, and the edge of the second rectangle would be A times R for an R between 0 and 1. And the edge of the third rectangle would be AR squared, and the edge of the next rectangle would be AR cubed, and the edge of the next rectangle would be AR to the fourth, forever and ever and ever. And he would then sum up the areas, okay, by multiplying the base, which is for the first rectangle the difference between A and AR, times the height. For the first triangle would be A to the n, right? And he would calculate the area for all these rectangles, and it would make a geometric a sum of a geometric series. Okay, and by working out that the R would approach 1, he reasoned that the geometric series could be that the area of under the curve would be represented with this expression, which of course is the familiar formula of integration, right, for y equals x to the n. One problem though, if he tries to apply it to y equals x to the negative 1, okay, he would then get this expression where the 0 is the denominator, and that's a problem. Okay. One of his contemporaries noticed, however, that when you try to apply Fermat's technique to the hyperbola, to y equals x to the negative 1, that the areas of all these squares are actually equal. Okay? And that means that the area of the hyperbola grows in equal increments as the distance grows geometrically. That is, the relation between the area and the distance is logarithmic. So the area under the hyperbolic curve from a fixed point to a point t is a function of t, and it is in fact log t, okay, for some base. Okay. So the question at this point is, okay, yes, we finally found a formula for the area underneath the hyperbola, but except that the major question here is, what is the base for the area underneath the hyperbola?